Synthesis of polystyrene sulfonic acid from waste polystyrene labware. In this video, we'll be turning labware such as these polystyrene pipettes into a useful organic catalyst. I started off by breaking up the polystyrene pipette into small pieces and adding it to a large beaker. I then set a water bath to 80 degrees and added a minimum volume of ethyl acetate into the beaker. For about 6 grams of polystyrene pipette, I added about 75 milliliters of ethyl acetate. I then added a magnetic stirring bar and I used my spatula to make sure that everything was submerged. I then stirred this at 80 degrees until the polystyrene pipette had fully dissolved. This process took around 20 minutes, but will depend on the size, shape and amount of polystyrene labware that you are using. I then filtered the solution to remove any impurities that wasn't dissolved in the ethyl acetate, such as the ink on the pipettes. This left me with a clear solution of polystyrene. I then used a small beaker to measure out about 50 milliliters of ethanol. This was going to be used to bring back the polystyrene that had dissolved in the ethyl acetate. I then slowly added the ethanol to the polystyrene solution, and upon swirling the beaker, this caused the dissolved polystyrene to precipitate back out of the ethyl acetate. I then removed the excess ethyl acetate and ethanol using vacuum filtration. This left me with a wet puck of polystyrene, which I left to dry on the filter for 1 hour. I then used my hands to tear apart the polystyrene puck into small pieces and place it on a glass petri dish. I then dried the polystyrene in an oven at 60 degrees for 24 hours. After 24 hours, I used a pestle and mortar to grind up the polystyrene, and I added 1 gram of this ground up polystyrene into a 250 milliliter round bottom flask. I then carefully measured out 10 milliliters of concentrated sulfuric acid and slowly added it to the flask along with a magnetic stirring bar. I then stirred this at 100 degrees for 1 hour using a dry glass rod to push down any pieces of polystyrene stuck to the side of the flask. After 1 hour, I then removed the flask from the stirring and the heat and placed it into an ice bath. I then used the glass pipette to slowly add cold water into the flask, before then directly adding a large amount of cold deionized water. I then decanted this back into the beaker of cold water and used vacuum filtration to isolate the PSSA. I then repeatedly washed the PSSA using cold deionized water, constantly testing the pH until it became neutral. I then dried the PSSA overnight at 70 degrees, and this left me with some dry crystals, which I could then grind up and add to a sample vial. We also conducted this experiment using cuvettes and petri dishes, which were also made out of polystyrene. As you can see, the product obtained is a slightly off-white colour compared to the ground up polystyrene that we started with before the sulfonation. The catalyst is now ready to be used in future reactions.